Exercise 2.2. Find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficients. Okay. In the question, they are given quadratic polynomials and they want to ask us to find the zeros for the quadratic polynomials, and as well as they want to verify the relationship between zeros and the coefficients. Okay. First question, x square minus 2x minus 8. Okay. So let us compare it with the standard form of quadratic polynomial equation, that is ax square plus bx plus c. Then we are getting the values of a, b, c as a is equal to 1, b is equal to minus 2 and c is equal to minus 8. Okay. Now, in order to find 0 for the quadratic polynomials, we want to find factor for the given expression. So I want to split this minus 2x into two terms such that the sum of those two terms, which is equal to minus 2x, and the product of the two terms, which is equal to x square into minus 8. Now I can split x square minus 2x minus 8 as x square plus 2x minus 4x minus 8. So if I take x as a common, I am getting x plus 2, and if I take minus 4 as common, I am getting x plus 2. So from this 2, again I am taking x plus 2 as common, then x plus 2 into x minus 4. If I want to equate these expressions to 0, then I am getting x plus 2 equal to 0 and x minus 4 is equal to 0, then which results in x is equal to minus 2 and x is equal to plus 4. Okay. So these are the zeros of the given quadratic polynomial. That is, for the values of minus 2 and 4, the given equation x square minus 2x minus 8 becoming 0. Okay. Now, if you want to verify the relation between the zeros and the coefficients, we know that sum of its zeros, which is equal to minus b by a, and the product of its zeros, which is equal to c by a. Okay. Now, second sum. The given quadratic polynomial is 4s square minus 4s plus 1. Okay. Let us compare it with the standard form of equation, that is as square plus bs plus c. Then we are getting the value of a is equal to 4, b is equal to minus 4 and c is equal to 1. Okay. Now, if we want to find 0 for the given polynomial, we have to split the middle terms into two subterms, in which the addition of these two subterms, which is equal to the middle term minus 4s, and the product of these two subterms, which is equal to the product of 4s square into 1. Hence, I can write 4s square minus 4s plus 1 as 4s square minus 4s plus 1 equal to 4s square minus 2s plus 1. So that I am getting, if I take 2s as common, 2s minus 1, and if I take minus 1 as common, 2s minus 1. So again from these two, I am taking 2s minus 1 as common, then I am getting 2s minus 1 into 2s minus 1. So if I equate this expression to 0, then I am getting the values of s is equal to 1 by 2 comma 1 by 2. So for the values of s, that is 1 by 2 comma 1 by 2, we are getting this equation 4s square minus 4s plus 1 as 0. Okay. Now, if you want to verify the relationship between the zeros and the coefficients, we know that the sum of the zeros, which is equal to minus b by a, and the product of the zeros, which is equal to c by a. Okay. Third problem. 6x square minus 7x minus 3. Let us compare this equation with the standard form of equation ax square plus bx plus c. Then we are getting the values of a, b and c as a is equal to 6, b is equal to minus 7 and c is equal to 3. Okay. Now, if you want to find zeros for the given equation, we want to split the middle term into two subterms, in which it satisfies two conditions. That is, the sum of these two subterms, which is equal to the middle term minus 7x, and the product of these two subterms, which is equal to the product of 6x square into minus 3, that is minus 18x square. So I can write 6x square minus 7x minus 3 as 6x square minus 7x minus 3 is equal to 6x square minus 9x plus 2x. So if you add, I am getting minus 7x, and if you multiply, I am getting 18x squared. Okay. Now, if I take 3x as common, I am getting 3x into 2x minus 3, and if I take 1 as common, 1 into 2x plus 3. So if I take 2x minus 3 as common from these two terms, I am getting 3x plus 1 into 2x minus 3. If we equate it to 0, we are getting 3x plus 1 is equal to 0 and 2x minus 3 is equal to 0. So the values of x are x is equal to minus 1 by 3 and x is equal to 3 by 2. So these are the two values of x, the given quadratic equation becoming 0. Hence these two are called the zeros of the given polynomial. In order to check the relationship between the zeros and their coefficients, we know that sum of zeros is equal to minus b by a and the product of its zeros is equal to c by a. Okay. For sum, the given equation is 4u square plus 8u. So when it is compared with the standard form of equation au square plus bu plus c, we are getting the values of a is equal to 4, b is equal to 8 and c is equal to 0. Okay. Now if you want to find the roots, the 0 for the given equation, we have to make factors for that equation. Okay. Now 4u square plus 8u. Now if p of u is equal to 0, then we are getting 4u square is equal to minus 8u. That is 4u is equal to minus 8 and u is equal to minus 8 by 4, which is minus 2. So simply here there is no constant term, so I am simply equating to 0. Then I am getting u is equal to minus 2. So u is equal to minus 2 is the value of u at which the given equation 4u square plus 8u becoming 0. Hence minus 2 is considered as the root for the given polynomial. Now to check the relationship, sum of its zeros, that is equal to minus 2, which is equal to minus b by a, and product of its roots, which is equal to c by a. Here c is 0, so c by a becomes also 0. Okay. Now coming to fifth question, that is t square minus 15. The given quadratic equation is t square minus 15. So it's compared with the standard form of equation, we are getting a is equal to 1 and b is equal to 0 and c is equal to minus 15. Okay, here there is no x term, so I want to simplify this equation just by equating with 0. So if t square minus 15 is equal to 0, then t is equal to plus or minus square root of 15. That is the root of the zeros of t are plus 15 and minus 15. Okay. Now if you want to check the relationship between them, so sum of these zeros is equal to plus root 15 plus of minus root 15, which is equal to minus b by a, and product of zeros, which is equal to minus root 15 to plus root 15, which is equal to c by a. Okay. Sixth problem. Given polynomial equation is 3x square minus x minus 4. Okay. When it compared with the standard form of equation, that is ax square plus bx plus c, we are getting the value of a is equal to 3, b is equal to minus 1 and c is equal to minus 4. Okay. Now, if we want to find 0 for this particular equation, we want to split the middle term into two subterms in which it satisfies two conditions. That is, the sum of its terms, which is equal to minus x, and the product of its terms, which is equal to minus 4 into 3x squared, that is 12x squared. So I can write 3x squared minus x minus 4 as 3x squared minus 4x plus 3x minus 4. See, if we add these two terms, we are getting minus x, and if we producting these two terms, we are getting minus 12x squared. Okay. Now, so if I take x as a common, then I am getting x into 3x minus 4 plus, if I take 1 as common, I am getting 3x minus 4. So in both terms I am taking 3x minus 4 as common, then I am getting x plus 1 into 3x minus 4. Okay. When I equate it to 0, I am getting 3x minus 4 equal to 0 and x minus 1 equal to 0. So that the values of x are 4 by 3 and values of x is minus 1. So these are the two values of x at which the given polynomial equation becoming 0. Hence plus 4 by 3 and minus 1 are the zeros for the given polynomial. Okay. Now If you want to find the relationship between the coefficients and the zeros, we know that the sum of the zeros, which is equal to minus b by a, and the product of its zeros, which is equal to c by a.